Now that we're familiar with the quotient rule, we can revisit differentiation of trigonometric functions and look at differentiating tan x. So, let's say that y is equal to tan x. Then, since tan x is equal to sin x over cos x, we can write y is equal to sin x over cos x. Now, if we're going to differentiate y with respect to x, we can identify from the form of the equation that we should be using the quotient rule. So let's put u is equal to sin x so that du by dx is equal to cos x, and let's put v equal to cos x so that dv by dx is negative sin x. Then, by the quotient rule, dy by dx is equal to v du by dx minus u dv by dx all over v squared, which is equal to cos x, which is v, times cos x, which is du by dx, negative u, which is sin x, times dv by dx, which is negative sin x, and this is all divided by cos squared x. We can rewrite as cos squared x times, remember a negative and another negative sign mean we have plus sin squared x, over cos squared x. And recall, sin squared x plus cos squared x is equal to 1, so that we have 1 over cos squared x, which is sec squared x, where sec x is 1 over cos x, sec x being the secant of x. It's worth noting that this derivative of tan x is something most people just remember, not something that they work out like this every time. It's important to understand the derivation shown here, but you should just try to remember that if y equals tan x, then dy by dx equals sec squared x. This will save you a lot of time in the future.